Welcome to the deep dive. Today, we're embarking on quite a mind-expanding journey. We're looking into the very nature of reality itself. We're going to explore how some, well, groundbreaking discoveries in modern physics are really challenging our fundamental perceptions. And perhaps surprisingly, how they seem to resonate with insights from, ancient wisdom traditions. We've pulled together a fascinating stack of sources, articles, research notes that really dig into the implications of what's being found at the subatomic level. It all seems to hint at this interconnected universe, something far grander than maybe we've ever imagined. Our mission, as always in this deep dive, is to sort of distill the most provocative insights from these discussions. We want to help you understand not just what physicists are discovering, but crucially, why it matters to your understanding of the world and maybe even your own place in it all. Think of it as, well, your shortcut to getting up to speed on the cosmos, hopefully with plenty of aha moments along the way.
It's genuinely fascinating, isn't it, how this seemingly very abstract, very rigorous world of physics is now pushing us to consider really radical new ideas about reality, prompting questions about assumptions we've maybe held for centuries without even realizing it. And we'll uncover how even the process of scientific discovery itself, the how of it, seems to rely on something. Well, something beyond pure intellect, something maybe not typically associated with the scientific method.
That's a captivating place to start because we do often picture scientists as these purely rational beings, right? Just poring over equations, driven only by cold, hard logic. But the sources we looked at highlight a surprising truth. Intuition. It plays a crucial, often kind of unacknowledged role in breakthroughs. So it seems it's not all about the lab coat and the calculator.
Not at all, apparently. Dr. Capra, for instance, he notes that while rational activity is, of course, a huge part of scientific research, it's, quote, not all there is to it. He points out that really profound new insights often tend to come suddenly and, characteristically, not when you're sitting at a desk working out equations, but maybe when relaxing, in the bath, or during a walk in the woods, on the beach, that kind of thing. It's like these moments of mental spaciousness when the conscious, logical mind steps back a bit. That's when the breakthroughs can happen. It suggests our brains are doing much more than just, crunching numbers. They're making connections on a deeper, maybe less obvious level.
That really does shift our perspective on what makes a scientist truly great. It's almost as if these moments of relaxation let them tap into something deeper, something beyond just conventional, linear thought. Are our sources suggesting a more maybe holistic, almost intuitive way of understanding is involved? They mention it opens them to higher rays of knowledge through finer faculties they might not even be fully aware of themselves. How should we interpret finer faculties here? Is it something mystical?
That's a really key point. When the sources mention finer faculties, they're not necessarily jumping straight to the mystical. It could mean a kind of heightened awareness or maybe enhanced pattern recognition, a different mode of thinking that isn't purely logical deduction. It's about being receptive, open to unexpected connections that the purely rational mind, if it's too focused, might just miss. It suggests that for the really big ideas, scientists tap into a broader spectrum of intelligence, not just intellect, but maybe drawing from a wider understanding, often unconsciously.
That makes a lot of sense. And for you listening, it's maybe worth considering your own experiences here. How often do your own breakthroughs, big or small, come not from forcing the issue, grinding away at it, but from stepping back, letting things percolate, allowing intuition to surface? I know for me, wrestling with a complex problem, I'll hit a wall, walk away, and then suddenly the solution just pops in. It seems the scientific process itself hints at this richer way of knowing, one that values quiet contemplation maybe just as much as intense focus.
Exactly. And it's a pattern you see at the highest levels of science. Suggests a pretty universal principle at play.
Okay, so moving from these intuitive leaks, let's turn to the specific discoveries that really started to shake things up. The things that challenged foundational physics, especially at the start of the last century. I'm talking about non-local connections in subatomic physics. These weren't just small additions to knowledge, they seemed to fundamentally rewrite the rules of reality.
Oh, absolutely. Dr. Capra's review of atomic and subatomic research really highlights this new kind of interconnectedness. It stunned the scientific community back then. Physicists realized that the universe is linked in ways far subtler than they had ever imagined. It completely shattered that classical view of just isolated particles bouncing around. And what's particularly striking is how this idea, this basic quantum interconnectedness, finds echoes in, say, Eastern mysticism, which has long talked about matter and phenomena being integral parts of a unified whole, not just isolated things. It's quite a profound alignment where modern science seems to be converging with very ancient philosophical thought.
To really get our heads around just how mind-bending this is, let's unpack a simplified version or a famous experiment. Well, it started as a thought experiment, later confirmed experimentally. It's called the Einstein-Podolsky-Rosen, or EPR, experiment. So imagine two electrons that are entangled. They're created together, designed to spin in opposite directions, so their total spin adds up to zero. Now, here's the setup. They're sent far apart, really far, one to New York, the other to Paris. Or maybe even Earth and the Moon. Doesn't matter how far. Okay, here's the paradox bit. When you measure the spin of particle 1, let's say you find it spinning up along a certain axis. You instantly know that particle two's spin must be down along that same axis. Instantly. But here's the real kicker. You can choose the axis of measurement, the direction you check the spin, at the very, very last minute, when the electrons are already thousands of miles apart. So the core question becomes, how does particle 2 instantly know which axis you chose for particle 1? There's no time for any normal signal limited by the speed of light to travel between them. This is where it gets really interesting, right? It seems to just defy our everyday understanding of space, time, and how information travels.
This was precisely the heart of a huge debate. A fierce one, actually, between two giants of physics, Einstein and Bohr. Einstein argued quite strongly that no signal could possibly travel faster than light, so this kind of instant communication was impossible. He famously called it spooky action at a distance. He felt there had to be some hidden variables, predetermined properties that decided the spin from the start, maintaining a kind of local reality. But Niels Bohr, he famously maintained that the whole two-particle system is actually an indivisible whole, linked by these instantaneous non-local connections that just transcend our conventional notions of information transfer. For Bohr, the system was fundamentally unified, no matter how far apart the parts were spatially.
So it sounds like Bohr's more radical idea, this indivisible whole, eventually won out. How exactly did Bell's theorem come into play? Did it provide that crucial, decisive evidence?
Yes, Bell's theorem was revolutionary. It wasn't just another theoretical idea. It provided a mathematical way to experimentally test this, to test whether Einstein's idea of local realism, the idea that objects have definite properties before measurement and nothing travels faster than light, was actually true. Bell showed that if local realism held true, there'd be mathematical limits on how correlated these entangled particles could be. But the experiments based on Bell's work, like those by Elaine Aspect and others later on, consistently show that nature violates those limits. They're more correlated than local realism allows, which basically means the universe really is fundamentally interconnected in this non-local way, defying Einstein's classical intuition. It strongly supported Bohr's view of a unified non-local reality.
That's just astonishing. So Bell's theorem effectively proved the universe is fundamentally interconnected, interdependent, and inseparable. And connecting this back, it really is a powerful scientific validation of some very old ideas, isn't it? Like the Buddhist sage Nagarjuna, who said hundreds of years ago, things derive their being and nature by mutual dependence and are nothing in themselves, verse. It's fascinating how a Buddhist sage articulated something so similar centuries ago. Can you elaborate a bit more on the parallels there? Between his philosophy of mutual dependence and quantum interconnectedness, what makes it more than just a surface similarity?
Well, it goes deeper than just a thematic link. Nagarjuna's philosophy, often called dependent origination or sometimes emptiness, isn't saying things don't exist. It's saying they lack inherent independent existence. Everything arises in dependence on other things, on conditions on its parts, on the mind perceiving it. This really mirrors the quantum view, where particles don't seem to have definite independent properties until they interact, until they relate to something else, like a measuring device. The very nature of what a thing is, whether it's a particle's spin or a philosophical concept in Nagarjuna's thought, is only understood through its relationships, its context. So quantum interconnectedness isn't just about two particles having a special link. It reflects this deeper idea that fundamental reality might be a web of relationships, where nothing is truly isolated or exists purely on its own. It's a kind of shared rejection of inherently separate, independent entities.
Okay, so the universe is fundamentally interconnected, echoing this ancient wisdom. But is this just a quantum thing, confined to the incredibly small? Our sources seem to push us further, suggesting these non-local connections might extend beyond the subatomic, pointing to possible connections with what they call finer parts of creation, maybe through radiations that attract each other. And they even mention something called the law of attraction of homogeneous species as potentially relevant. How do we approach these more, well, conceptual terms from our sources? They sound less like standard physics terms.
That's an important distinction to make. These aren't conventional scientific laws like, say, gravity, as understood in mainstream physics today. But our sources introduce these concepts possibly to bridge the gap, to connect the known quantum world to a potentially broader, maybe more subtle, reality. The idea of finer parts of creation suggests, perhaps, a multi-layered reality, dimensions or aspects beyond what our current instruments typically pick up. And this law of attraction of homogeneous species, while not standard physics, offers an intriguing lens. It makes you think about how non-local connections might operate on a grander scale, maybe hinting at unexplored dynamics where similar types of things, maybe radiations or subtle energies, naturally draw together. It encourages thinking about resonance and coherence, not just in terms of known physical forces, but maybe in a more expansive, perhaps energetic sense.
That's a truly expansive thought. It implies modern physics shows that even at the macroscopic level, everyday objects aren't truly distinct, isolated entities. They are, quote, inseparably linked to their environment. Their properties only make sense through their interaction with the rest of the world. And our sources take this even further, suggesting this interaction reaches out, connecting to the universe at large, and potentially even to finer planes of existence, planes from which radiations might condense into our universe, becoming tangible, capable of physical experience.
Precisely. And this flips the script on the void, or empty space. It's not empty at all. It's a dynamic field, full of connections and potentiality. The universe isn't just a collection of separate objects anymore. It's more like an ongoing process of emergence and interaction. This idea really challenges the very notion of things as independent, stable entities. It invites us to see everything as more fluid, as interconnected events. And extending that line of thought towards finer planes suggests a continuum of reality, perhaps, where our observable universe is just one manifestation, one layer of a much larger multi-dimensional cosmic process.
And even astronomy seems to point in this direction, lending more weight to this idea of universal interconnectedness. Frederick Hoyle, the astronomer, noted that everyday conditions, even down to tiny details, are closely integrated to the grand-scale features of the universe. So it's not just the subatomic world that's connected, it's everything, from the quantum foam right up to the cosmic web. The void, as you said, isn't empty. It's a dynamic quantity of paramount importance, a bustling field of activity. Okay, building on this deep interconnectedness, our sources then introduce us to another profoundly imaginative area, David Bohm's work, specifically his notion of unbroken dynamic wholeness. Some even describe this as an attempt to bootstrap space-time itself. What exactly did Bohm mean by that, this idea of bootstrapping space and time?
Right. Bohm was deeply influenced by quantum mechanics, but he was searching for a more holistic view of reality. He took this idea of non-local connections and pushed it even further. He proposed there's a deeper level, a non-manifest or implicate order underlying everything. In this implicate order, connections don't rely on locality, on things being near each other in space and time. Instead, there's this quality of enfoldment. When the sources mention bootstrapping space-time, they're referring to Bohm's really radical idea that space and time aren't the fundamental fixed backdrop we usually assume them to be. Instead, they emerge from this deeper, implicate order. They unfold from a dynamic process he called the holomovement. It's an attempt to find a common ground, an underlying reality from which both quantum weirdness and the large-scale structure of the cosmos could arise.
That's incredibly abstract, but definitely fascinating. To help us grasp this enfoldment, Bohm famously used the analogy of a hologram. What really stands out about a hologram, as our sources note, is that each of its parts, in some sense, contains the whole. If you take just a small piece of the photographic plate that stores a hologram and shine a laser through it, you can still reconstruct the entire image. Maybe fuzzier, but the whole thing is there. It's like the information for the whole picture is somehow distributed everywhere on the plate. And this wasn't just a handy metaphor for Bohm, was it? He saw it as a clue to how reality itself might actually operate.
Exactly. For Bohm, the universe wasn't just like a hologram. In a way, it is a kind of gigantic flowing hologram. He extended this to his concept of the holomovement. This describes the fundamental dynamic nature of reality itself, the ground from which all the forms we see in the material universe, what he called the explicate order, unfold and flow. His goal was to study the order that's enfolded within this movement, not just the structure of objects we see. So space and time themselves are part of this unfolding, emerging from the holomovement rather than being pre-existing containers. It was really an attempt to provide a unified basis for quantum theory and relativity, which, as you know, have always been difficult to reconcile.
Okay, and here's where Bohm's work gets really provocative, pushing the boundaries way beyond conventional physics. Our sources reveal that to fully understand this implicate order, this holomovement, Bohm found it, quote, necessary to regard consciousness as an essential feature of it all. Not just a byproduct of complex brains, but something fundamental woven into the underlying dynamic of reality.
Yes, this is a truly radical departure. He didn't see mind and matter as separate things where one causes the other. Instead, he viewed them as interdependent and correlated. You can think of them almost like two different faces or two mutually enfolding projections of a single higher reality, a reality which is itself neither just matter or just consciousness. They arise together, mutually enfolded, from that same underlying hollow movement. This offers a stunningly different perspective on the mind-body problem, on the relationship between our inner subjective world and the outer objective world. It suggests they originate from a shared, deeper source, rather than one simply creating the other. It implies consciousness isn't just something that happens in brains, but is somehow inherent in the very fabric of existence itself.
Now, while Bohm's theory is, as our sources note, still quite speculative, maybe more qualitative than quantitative at this stage, its resonance with other cutting-edge ideas, like Jeffrey Chew's bootstrap theory, which also explored how particles might get their properties from their interrelations, a kind of self-consistent, self-generating universe. It suggests a possible future direction for physics, a future where consciousness might need to be included somehow in our fundamental understanding of physical phenomena. Our sources even suggest these two approaches, Bohm's and Chew's, might represent some of the most imaginative and philosophically deep ways of thinking about physical reality developed so far. So, after this incredible journey through intuition and science, quantum entanglement, Bohm's holographic universe, what does this all mean? What are the implications for us, for our place in the universe? The evidence building up, especially highlighted in our sources, strongly suggests we need to look beyond our universe. It's a call to really expand our horizons far beyond what we typically think of as reality.
And our sources draw a really crucial distinction here. They point out that investigations today often tend to equate the universe to creation. And this, they state quite clearly, is a great error. The universe, as cosmologists usually define it, everything we can observe or infer from the Big Bang outwards, that's one thing. But creation, as presented here, is something far, far vaster. The ultimate, all-encompassing reality, perhaps, from which our entire known universe is just one small part. Making this distinction is incredibly important, as it opens the door to a much grander, potentially multidimensional reality than our current scientific models typically encompass.
That's a truly humbling thought, isn't it? To imagine that our entire universe, with all its billions of galaxies, nebulae, stars, planets, all its wonders, in the grand scheme of this great and wider creation, it forms less than a pinpoint. That puts everything into a profound, almost unimaginable perspective. Our whole reality is just a tiny speck within something infinitely larger.
It absolutely does. And it immediately raises a critical question. If there is this wider creation, how could we possibly perceive it? The text we reviewed suggests that we, as humans, might possess finer organs of perception capable of doing just that. Now, that's a provocative concept. Our sources are implying an innate human capacity, maybe latent, to perceive these broader dimensions beyond our 5 physical senses, if only we learn how to develop them, how to use them. The call, as they put it, is to become more familiar with them and press them progressively into activity.
This feels like such a powerful takeaway message. Modern physics, far from making the world seem cold and mechanical or isolating us with complexity, it's actually pointing us towards this deeply interconnected reality, towards a dynamic void, full of potential, and even highlighting the fundamental role of consciousness. It feels like it's opening doors to what our sources call nascent wisdom, a kind of budding understanding of a far richer, more intricate cosmos, a cosmos potentially accessible not just through telescopes and particle accelerators, but perhaps through developing our own untapped inner potential. So we've journeyed today from the surprising role of intuition in scientific discovery to the baffling mysteries of quantum entanglement that just defy common sense. Then on to Bohm's incredible vision of a holographic enfolding universe, and this idea of consciousness being fundamental to reality itself. It seems clear that physics isn't just about particles and forces anymore, is it? It's delving into profound connections, hinting at a reality far richer and more dynamic than we usually perceive. And these insights aren't just for physicists in labs. They're really for anyone curious about the deepest nature of existence and, well, our place within it all.
Absolutely. And this deep dive into modern physics and its surprising, often stunning, alignments with ancient wisdom leaves us with a really powerful thought to ponder. If the universe truly is fundamentally interconnected, if our everyday understanding of space and time is maybe just an emergent feature or projection of some deeper implicate order, then what might your own finer organs of perception, as our sources put it, be capable of discovering? What unseen truths might you uncover, both within yourself and perhaps in the vast, multi-layered creation that surrounds us, if you dare to look beyond the obvious? Definitely something to think about until our next deep dive.